Welcome viewers, in this video we'll see the combination of resistor. The resistors can be connected in two different ways, either series or parallel. So we'll see this one by one. First we'll see the series combination. Series combination means the resistors are connected end to end. One end of the resistor connected to another end of the resistor, so that it is called a series combination. You can refer the diagram here. R1, R2, R3. Three resistors are connected in series. One end of the resistor connected to another resistor, thereby another resistor. R1, R2, R3. This is called a series combination. It is given with a supply voltage V. The current flowing is I. This terminal is A. This terminal will be B. The important thing in this series combination is the same current is flowing through all three resistors. Current is same. Only one current I is flowing through R1, R2 and R3. Because of series combination, series connected, only the current I is flowing through all the resistors. This is the one important point. This V1 is the voltage drop across R1. V2 is the voltage drop across R2. V3 is voltage drop across R3. So the V is the applied voltage. This voltage will be dropped across R1, R2 and R3, depends upon the R value. So depends upon the R value, the voltage will be dropped. So this V1, V2, V3, sum of these three is nothing but total voltage. Total voltage V equal to V1 plus V2 plus V3. Because this V only dropped across these three resistors. So V equal to V1, V2, V3. So the two important thing, one is current is equal in all the resistors. Second one, the voltage, applied voltage V equal to sum of V1, V2 and V3. That is V equal to V1 plus V2 plus V3. So these two are important points in this series combination. So these three resistors can be converted into single resistor, equivalent resistance, total resistance between the terminal A and B. Now we'll see what is the total resistance in case of seriously connected. We'll see the expression. How will you find the total resistance? So in this is given, the description is given, since there is only one closed loop, only one current is flowing, the first one. In other words, if the current is same through all the resistor, this combination is called a series combination. The series combination is easily identified. If the current is same in all the resistor, means the same current is flowing, means that resistors are connected in series combination. Now V is the applied voltage, I is the series current. V1, V2, V3 is nothing but voltage drop across resistor R1, R2, R3. First we will find what is the voltage across V1. V1 is nothing but I into R1. V equal to IR. V1 equal to I into R1. Voltage drop across the resistor R1, so that it is I into R1. Voltage drop across R2 is V2 equal to I R2. Similarly V3 is I R3. The current is same in all the cases, only the resistor and voltage will be different. The current is same. We already discussed the total voltage equal to V1 plus V2 plus V3. Voltage drop across R1, R2 and R3. That is the important thing in the series combination that we already discussed. The current is equal, potential is different, the sum of all potential is equal to total potential. Now we'll substitute this value. V1 is nothing but IR1, V2 is IR2, V3 is IR3. The current is same. So we'll take the current outside. V equal to I into the I is taken outside, so that R1 plus R2 plus R3. So this R1 plus R2 plus R3 is nothing but a total resistance, RT. RT is nothing but R1 plus R2 plus R3. So in the series combination, the total resistance is nothing but sum of individual resistance. So the series combination means very simple. We need to add all the individual resistance. That will give the total resistance. So that is given. the total resistance is equal to the sum of the individual resistors. We need to add all the resistors, right? So in this series combination, first important point is the current is equal, same amount of current is flowing. Potential drop across each resistor, sum of potential drop across each resistor is total potential, V equal to V1 plus V2 plus V3. So by analyzing, we found that the total resistance equal to sum of individual resistance for series combination. Now we'll go to the parallel combination. What is parallel combination? If one end of all the resistor is joined to a common point and other ends are joined to the another common point, then the combination is said to be parallel combination between the two common points. The one end of all the resistors are connected in one common point, another end is connected to another common point, then that combination is said to be parallel. Now I will refer this diagram so that it is easier. See that the three resistors available, R1, R2, R3. This one end of all the resistors are connected together. This is common point A. Another end also connected together. Another end of all the three resistors are connected together. This is point B. So this is common point, another common point. Right? In series resistor means it is connected end to end, but parallel combination it is connected, one ends are connected together, another ends are connected together. This end is A, this end is B. It is supplied with the supply voltage V. Supply voltage V is given. This is the current, total current I is flowing through the resistor. I is flowing through the circuit. So the current I is flowing. At this point, what will happen? The current will be divided because three different paths available. So the current will be divided. I1, I2, I3. Current is divided. In case of series combination, the voltage is divided. Now the current is splitted. Current flowing through R1 is I1, R2 is I2, R3 is I3. So total current I equal to I1 plus I2 plus I3. So there is an important thing in this parallel combination. In series combination, V equal to V1 plus V2 plus V3. But here the current is, total current equal to sum of current flowing through each resistor. What about the voltage? The same voltage is applied across R1, R2 and R3. The voltage what we applied V is available across R3, R2 as well as R1. The voltage will be same. The current will be different. So this parallel combination can be converted into single resistor, total resistor or equivalent resistor between A and B with a supply voltage V. We will see what is the resistance R. How will you find what is the expression for total resistance in case of parallel combination? We will see now. So V is the applied voltage. I1 and I2, I3 is the current flowing through R1, R2 and R3. So by Ohm's law, we will find the I value. I equal to I1 equal to V by R1. I already told V is same across all the resistor. Only the current will be different. So I1 is the current flowing through resistor R1. So I1 equal to V by R1. Similarly, I2 equal to V by R2. I3 equal to V by R3. And another important thing, total current equal to sum of this current flowing through the end resistors. Previous in the series combination, V equal to V1 plus V2 plus V3. Here I equal to I1 plus I2 plus I3. Now substitute the value, V by R1 plus V by R2 plus V by R3. The voltage is common, so we can take the voltage outside. So what we have, I equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So this is nothing but the total resistance, 1 by RT. So I equal to V into 1 by RT. So that we can write I equal to V by RT. So what is this RT is nothing but 1 by R1 plus 1 by R2 plus 1 by R3. Now we'll see the further simplification. So 1 by R2 equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now we'll go for a simplification. We'll take the LCM. 1 by RT equal to, so the R1, R2, R3, 3 terms available. So we will take the LCM as R1, R2, R3, all 3. So here R1 is available, R2 and R3 is not available. So it is R2 plus R3. Here R2 is available in the common LCM. So R1 and R3 is multiplied here. Plus here R3 is available. So R1 and R2 is multiplied. So it is R2 R3 plus R1 R3 plus R1 R2 divided by R1 R2 R3. So this is 1 by RT. What about RT total resistance? It is inverse. Just you have to change the numerator and denominator. So R1 R2 R3 divided by R1 R2 R2 R3 plus R3 R1. So this is the total resistance in case of the parallel combination. The 3 resistors. Suppose the 2 resistors are available. What is the total resistance? 2 resistors are available. 1 by RT equal to 1 by R1 plus 1 by R2. Only 2 resistors. Normally we will refer the 2 resistors. This formula only we are frequently using. So 1 by RT equal to, take the LCM, R1 R2, 2 terms available. Here R1 is there, so we need to multiply with R2. Here R2 is there, so we need to multiply with R1. So this is 1 by RT. What is RT? Just you have to interchange numerator and denominator, reciprocal. You have to take the reciprocal. So R1 R2 divided by R1 plus R2. So this is a standard formula. In case of parallel combination, the resultant or equivalent or total resistance is R1 R2 divided by R1 plus R2. Multiply both the resistor divided by sum of both the resistors. R1 R2 divided by R1 plus R2. So now we got the expression for total resistance in case of parallel combination for 3 resistor as well as 2 resistor. Now we'll see one problem. So in this problem, we need to calculate the equivalent resistance of the following combination of resistor and also source current. So one circuit diagram is given. In this, we need to find what is the total resistance and also what is the total current, source current. So here 12 ohm resistor available, 16 ohm and 4 ohm. There is another 6 ohm available and 40 ohm available. Now we need to simplify this resistor by using this series parallel combination. By using series parallel combination, we can simplify this circuit. So in this circuit, it is, by seeing this, it is clear these two are connected in parallel. By seeing the diagram, it is very clear that 12 ohm and 6 ohm are connected in parallel. There is no overlap here. Suppose we cannot take this because this is connected, another 40 ohm, here 6 ohm is there. Here there is no overlap. This 12 ohm and 6 ohm are connected in parallel. Now we'll change this. Now we'll find the equivalent resistance for this 12 ohm and 16 ohm. Right. So the diagram is available here. See this. This 12 ohm and 6 ohm are connected in parallel. We'll take this is R1 and this is R2. What is the total resistance in case of 2 resistors connected in parallel? R1 into R2 divided by R1 plus R2. So that is equal to 12 into 6 divided by 12 plus 6. That is 72 divided by 18. It is 4 ohm. So the combination of these two resistors are parallel, right? While simplifying this, what we got is a 4 ohm. These two resistors connected in parallel. By finding the total resistance, it is 4 ohm. So this parallel combination can be replaced with a single resistor of 4 ohm. This 4 ohm, right? This 4 ohm is replaced, right? So the 12 ohm and 6 ohm resistors connected in parallel, that equivalent resistance we calculated 4 ohm, so that it is replaced with 4 ohm. Now by seeing this diagram, it is very clear. This 4 ohm and 16 ohm are connected in series. There is no overlap. Easily we can identify these two are in series. Right? Now we'll go for the further simplification. See this 4 ohm and 16 ohm. This 4 ohm and 16. We'll take this R1 and R2. So if the resistors are connected in series, what is the total resistance? R1 plus R2. We need to add both the resistor. 4 ohm plus 16 ohm. That is 20 ohm. Right? So the 4 ohm and 60 ohm are connected in series, mean the total resistance is 4 plus 16, 20 ohm. So this combination now replaced with a single resistor 20 ohm. We have one more resistor available, 40 ohm. So that is connected between 16 and 4 ohm. So by seeing this diagram, it is very clear. This 20 ohm and 40 ohm are connected in parallel. There is no overlap. These two are connected in parallel now. Now we can replace this with a single resistor. I will go for this further. See, this 20 ohm and 40 ohm are connected in parallel. What is the formula? RT equal to R1 R2 divided by R1 plus R2. For simplification, we are taking this R1 and R2. Right? This is not, there is no standard. This for this combination, we are taking 20 ohm as R1, 40 ohm as R2. So 20 into 40 divided by 20 plus 40. So that is equal to 800 divided by 60, that is equal to 13.33 ohm. 13.33 ohm. The combination, parallel combination of this 20 ohm and 40 ohm, the equivalent resistance is 13.33 ohm. So this 2040, this combination can be replaced with this 13.33 ohm. That is replaced. That parallel combination is replaced with 13.33 ohm. Here another 4 ohm is available. So by seeing this diagram, it is clear these two are connected in series. The equivalent resistance is sum of these two. 13.33 plus 4 is nothing but 17.33. Right? Now we'll see this diagram. So this 17.33 ohm. Then supply voltage is 50 volt and the current is I. Now it is converted into only single resistor. Right? Every series and parallel combination resistors are combined resistors are identified, and finally we got only one resistor. So from this diagram we can easily identify what is the current. Right? So the total resistance is nothing but 17.33 ohm. One question is total resistance. So we calculated total resistance equal to 17.33 ohm. Then what is the current? I equal to V by R. V is available and R also available. V is 50 volt and R is 17.33 ohm. So we can find the total current or source current, that is equal to V by R. V is 50, R is 17.33. So that after simplification we got 2.88 ampere. So the total current or source current is 2.88 ampere. So in this problem, there are series and parallel connector resistors are there. That is simplified and equivalent resistance is calculated. Finally, we got only one resistor, total resistance of 13.33 ohm. From that, we calculated total current or source current also. So in this video, we discuss about the series combination of resistor. What is the equivalent formula? Parallel combination of resistor. What is the equivalent formula? Based on that, we solved one problem. Thank you.